In this video, we are going to introduce our work, AlgoPlan, supporting planning in algorithmic problem solving with subgoal diagrams. Algorithmic problem solving refers to problem solving where learners need to design algorithms that solve the problem. Also, they need to implement it. The problem normally has a tight time and space constraint, so learners need to design efficient solution. Algorithmic problem solving involves multiple stages, such as solution planning, where the learner sketches the overall solution, and implementing, where learners implement the solution plan, and testing the implementation. However, novice learners often skip the solution planning. Moreover, even if the learners came up with the solution plan, they do not properly connect their plan to the code, so they fail to solve the problem. To support the solution planning, research introduced several representations that reveal the solution plans during the problem-solving process. An example of the representation is flowchart, which represent the flow of execution with specific operations. Learners can sketch the code execution without actual coding, but it only captures low-level details of the solution. However, learners mainly struggle from designing high-level components, such as solution techniques and subproblems, which cannot be well captured in the low-level details. To address the challenge, we introduce representation called subgoal diagram, which shows high-level components using subgoals. Instead of focusing on operation-level details, learners can design high-level plans of the solution. AlgoPlan allows learners to design the high-level solution plan with subgoal diagrams, improve their solution plan by comparison with a reference diagram, and connect the solution plan with the actual code. AlgoPlan consists of 3 stages: diagram generation, diagram comparison, and implementation. In diagram generation stage, learners can design their high-level solution plan. The skeleton diagram is provided for scaffolding learners to come up with the plan. In diagram comparison stage, learners can compare their solution plan with a reference diagram, which represent a correct solution. In this stage, learners can correct their plan or get insights about how to improve it. In implementation stage, learners can implement the code with the solution plan. To support connecting between the plan and the code, the system provides a set of comments that represent subgoals of the solution. Also, the system provides block orders, which visually represent the corresponding subgoal diagram node. We conducted a preliminary study to evaluate AlgoPlan. The result shows that the participants were able to easily formulate ideas into a diagram structure. The reference diagram was useful for improving their plan, and the diagram acted as an outline, which helps participants remember what to implement. We have the following future work. First, we are going to more rigorously evaluate the effect of the subgoal diagrams. Second, we are going to explore how to make use of the subgoal diagrams in the problem-solving process. Third, we are going to reduce the authoring cost of the subgoal diagrams, especially by designing a learner sourcing workflow. Thank you for listening.